I didn't have a clue what to talk about when I was asked, so I made some things up, and hopefully this will help a little bit, even though it repeats some of the things we've heard, and it's definitely not as interesting as the previous two. However, I should define what food engineering is. It's the application of chemical engineering principles to large-scale production of food. And as such, it's the largest industry in Canada and in the world, as a matter of fact. Food engineering sort of sits at an intersection of a number of different sciences between food science, chemical engineering, and biochemistry. And the goals are to provide and manufacture food products that are safe, nutritious, and attractive, and cost-effective in that order. Okay? The industry needs to have materials made that are safe, otherwise you ruin the company. They need to be nutritious because the public demands it. It needs to be attractive because you have to sell it. It's got to be cost-effective, otherwise you go out of business. Now, when we talk about global engineering, we have to think about engineers working in a global context. And in effect, most of us are now working in a global context. The globalization takes many forms. It referred to the fact that companies are global. Their reaches over many, many different countries. And the result of that is that technological developments move very rapidly. When I was an undergraduate, an electronic device or an idea would take about 15 years to get from here to India or to Africa. Now it takes about 3 weeks. So the internet makes everything accessible now, and this was an example out of Bangladesh, since we're talking Bangladesh today by accident. We were there and we saw these. This is a local transport little taxi, 15 guys in that thing. The gentleman said to his son as he got out, be sure to email me when you get there. So it gives you an idea of how pervasive the internet and the email is at this point. Looking at what we do in Toronto, engineering design of large projects is absolutely global now. For example, a typical large project, the process design would be done in Toronto. On the internet, they would shoot down the specifications to India, where the drawings would be done overnight because the time difference is 10.5 hours. The drawings would be back in the office the next morning, and onwards they go. Once the drawings are done, the specialized equipment is fabricated in the US and EU at this point, or Japan, or Korea. More routine pieces of equipment are made in China. The construction takes place in Saudi Arabia by French and Chinese contractors, and Canadians and Americans started up. So you can see you have to be intertwined with all these different people. What happens? I still see things here, but I don't see it on the screen. You see it? Oh, okay, good. I lost it here. Another area in food specifically is edible oil processing. We use oils from all over the world, and what we use depends on the price of the day, and the process is adjusted for the source of oil that is the cheapest. So we can get palm oil from the developing countries in South America, Asia, or Indonesia, or soy oil from the highly developed mechanized agriculture of US, Brazil, and Canada, sunflower for East and Central Europe, and we can use these interchangeably. The effect of the food industry is important, but a lot of the food in the world is grown locally and it doesn't go through any processing by an industry whatsoever. And so I have to talk a little bit about what I worked on and the effect it may have in globalization. Micronutrients, as the definition there shows, are critical to your growth. You think of typically most micronutrients you would think about are vitamins, or alternately what they call minerals, but really are trace elements, most of them metals. 3 micronutrients have been identified as causing adverse health effects, including quite serious disease, in 2 billion people, 1 in 3. So we're looking at the same sort of large-scale problem that Professor Chen has pointed out with regard to water. And iodine is the one that's been most well addressed at this point due to the work of the Kiwanis Club and UNICEF. But iodine deficiency reduces the IQ of people as they're growing up. The little guy on the right, he's been stunted in growth by lack of iodine. He's from Nepal. And by not having enough iodine in your diet, and when you're a baby or when you're young, can drop the IQ of the person by 70 points. So going from a an average engineer in the room, I assume your average IQ here is 125. Dropping that down by 50 would put you down to where an average 3 or 4-year-old is. And so it shows you how huge impact on a whole nation this could be. Because if you don't have intelligent people that can do intelligent things, you automatically are depressing the standard of living that's there. Iron is even more pervasive. Lack of iodine comes from being too far away from the sea, because sea has ample amounts of iodine. Further away you move, the less iodine there is. But in the case of iron, iron deficiency is widespread, even though iron is one of the most widely available metals in the world. Not all of it is bioavailable. So again, loss of energy, anemia, maternal mortality, impaired development. There are approximately 500,000 women that die every year from the lack of iron in their diet. It's just a huge number to contemplate. Vitamin A results in essentially blindness in the worst case, and it is indeed the largest single source of impaired neural development. And the numbers, again, are staggering. Somewhere between 250,000 to 500,000 children a year develop blindness due to lack of vitamin A in their diet, and half of them die within a year because poor countries don't have an infrastructure to support a blind child, who has other problems as well. Now, the interesting thing is micronutrients are very inexpensive, and many of them can be just really added as chemicals. Unfortunately, most of them are quite reactive. That's why you need them in your body. And they're quite unstable as a result. Not only that, they tend to interact. And this is where chemical engineering comes into the system. So the challenge is to deliver the micronutrients at the right dose level, in the required time, in the required form, and at a reasonable cost.